Okay, everyone, I just wanted to show you the uranium trioxide that I made before I start weighing it out. You can see it doesn't look like the camera is really capturing the color really well because in reality most of it is a reddish orange. But you can see a few little specks of something that looks like it's more yellowish. Again, IRL, it's much easier to see that shit. But anyway, as it turns out, according to Atomistry, there are two forms of uranium trioxide. The reddish one is supposed to be a polymeric form, and the yellow one is, I guess, independent uranium trioxide molecules? I don't know. Is this fucking shit molecular? Probably not. Anyway, so as far as I can tell, it is not the hydrate. I don't think so. According to Atomistry, if you heat up the yellow one, it will convert back into the red one, and that is indeed what I have observed. It takes a while to convert to the yellow one, and it seems to be doing it even inside of a sealed vial, so I'm not sure that it has anything to do with it becoming hydrated. Alright, so we've got our water bath here. What I'm going to do is we're going to go ahead and put this on here and add our sulfuric acid to it. Okay, alright, something is happening actually. Oh, there is some fissification taking place. I know, very technical terms, right? Okay, cool. Well, let's just let it do its thing here on the heat bath, and we will see what we get. Okay, I was prepared for this to be difficult, but I don't really think it's going to be all that difficult. It seems to be dissolving fairly readily, which is a great sign. That's awesome, man. Look at that shit go. That is fantastic. Alright, people, check it out. Much thanks to my Patreon donors. You guys fucking rock. We got another stir plate. Thank God. Man, I tell you what, doing things the old-fashioned way is about a pain in the fucking ass. So, what we are going to do to break this thing in is we are going to try the synthesis of the sodium uranate on this thing. Seems like a nice reaction to pop its cherry with, don't you think? So, now that I'm done being crude. Alright, so I don't have any kind of protocol for this. I'm just putting this one together from pieces of information I have found. So, the first thing I'm going to do is I'm going to add a little bit of water to this, since this is supposed to readily react to form uranic acid with water. We're not going to leave it like that for long. Alright, now we are going to add some aqueous sodium hydroxide to this. And we are going to find out what happens. Wow, okay. There we go. Now, sodium uranate is insoluble in water. Turn on the heat here. I'm going to let it stir for a little while, and then we will come back and check on it and see what it has produced. Okay, so here is our mixture of uranium trioxide and potassium chlorate. And I've got the Bunsen burner out for this one, since it just says to heat it, not to heat it strongly. So I think the Mecker burner is going a little overboard for this one. So I'm going to get this going, and then I'm going to kind of stand back a little bit and let it do its thing, because I'm not really sure how this is going to go down. It may be totally calm and benevolent, or it may decide to get evil on us. So I don't want it getting evil on me, you know, with little warning. I don't like surprises like that. All right. Oh, shit. Is it happening? Well, that was kind of anticlimactic. But hey, who cares if it worked? I'm going to try adding a little bit more in there, because it doesn't look like it all reacted. Alright. Bitchin'. Okay, well, I figured that was going to be a major pain in the ass, but when I added water to the solid here, it dissolved readily, except for the presumed potassium uranate, which is indeed the right color. Now, what I think is really interesting here is that in the sodium uranate experiment, we are also getting an insoluble material of a very similar color, which is exactly what we should expect to see. I'm going to have to ask the uranium dude to take a look at this to confirm my suspicion, but I very much think that this is it, man. So that's pretty goddamn cool. I'm going to filter them off and dry them and put them in the inventory. Now, I'm not sure why this appears that it is not all reacting for some reason. Maybe it will eventually now that it's hotter and I keep stirring it. I mean, there is several grams of potassium hydroxide in there already, so I mean, I have a hard time believing it's, you know, not enough of that stuff. As for our uranyl sulfate, it is evaporating down nicely. It's not crystallizing, but I mean, who cares? I'm thinking I cannot live with this contamination in this shit. It's just driving me nuts. So what I'm thinking of doing is just letting this cool down, dilute it a little bit, and then just with a glass pipette, just transferring this into a vial or something like that. Because we're going to need this in solution form anyway for the barium salt metathesis reactions. So I might as well just save it as it is. And happily, there shouldn't be hardly any excess sulfuric acid at all. So that should make things pretty convenient. I mean, that's pretty goddamn awesome. So, given all of this, and given how long the video is getting, I'm going to go ahead and end it here. As always, I will post pictures of the final products on Facebook when it's all said and done, once they're filtered off and dried and everything. And you can always see that kind of stuff there. So, if you like this video, give it a thumbs up. If you didn't like it, give it a thumbs down. Subscribe, comment, share the video. And until the next one, y'all, I will see you later.